A 3 by 3 table starts with every entry equal to 0 and is modified using the following steps. 1. Adding 1 to all three numbers in any row. 2. Adding 2 to all three numbers in any column. After step 1 has been used a total number of A times and step 2 has been used a total number of B times, the table appears as shown. What is the value of A plus B? So the approach to this question, I believe, is just to concentrate on the smallest numbers first and then work your way up from there. So the smallest number is that 1. So obviously I have to make that a 1, and I do it with step this one, the one that they're calling A, and then this is they're calling B. So let's do an A. If I do an A on row 1, that'll become 1, 1, 1. Okay? And then now we get to what's the next biggest number? That's this one, 2. So obviously I have to make that a 2 eventually, and therefore I have to add 1 to it. So I have implemented another step A. Okay, let's keep going here. So the next one, what's the next number? 3 is the in chronological order. So I gotta add at least 1 there. So that's another step A. Okay, now what's the next one? I believe there's no 4, so 5. Actually, you know what? I wanna continue with just those 3 numbers because I think I can make those 1, 3, 2, and then I'll move on to the other 2 columns. I think that's probably the better way. So let me. Well, this is a 1, so I can't do anything there because I can't change that. But I can do something with this guy, and I'll just add 1 to there and make it 2, 2, 2. And if I do that, then that will now become a 2, and that's a 1. So I'm very close to completing that column. So if I do one more A, I get to this point, and you will see that I have completed that middle column, and that is great. So now I just have to concentrate on those 2 columns, the first column and the third column. All right, let's do that. So now I'm going to implement a B. A B, if you read the question, involves adding a 2 to the numbers of any column. So let's add it to, it doesn't really matter which column you start with. Let's just start with that third column. So the other 2 would stay the same, but if I had 2, that would become 1, 2, 3, 5, and 4. Okay, let's, I need to make it a 5, 7, 6 for this column. So let's do another B. So that would be, this will remain 1, 3, 2, 1, 3, 2, and that would be 5, 7, and 6. Okay, I have completed column 2 and 3. Now I just have to concentrate on the first column. A B will do it. Well, it will at least help. 3, 5, and 4. Everything else stays the same. Another B would be 5, 7, and 6. And then finally, one more B would be 7, 9, and 8. And I think that completes the entire box, whatever you want to call it, table. Okay, so how many A's and how many B's did I get? So I did 1, 2, 3, 4, 5, 6 A's, and B's 1, 2, 3, 4, 5. 5 B's. So they want A plus B. Well, A plus B is 6 plus 5, which is 11. For how many integers m does the line with the equation y equals mx intersect the line segment with the endpoints 2024 and 4202? Let's make a table, or a graph I should say, and let's see what happens. So this is certainly not going to be drawn to scale, but 2024, let's just say it's approximately here. So 2024, and then the other one 4202, oh boy, so that's way up here somewhere, and like I said, that's not even close to being drawn to scale, but for the line is something like that. Well, at least you understand the fact that it would have a negative slope. And then we have y equals mx. So if y is equal to mx, then one thing for sure we know is that it passes through the origin, since 0, 0 would satisfy. So we have some situation like this. We don't know what m is. So because we don't know what m is, we don't know what the slope would be. So if we don't know the slope, we don't know exactly, where the line goes, but we do know that it passes through the origin. So that's the basic setup. And what they're saying is that this intersection point is very crucial. They want that intersection point to be obtained in a way that m is an integer. So that's what they're basically saying. So how many integers does the line intersect at the endpoints? Now they're going to intersect in many, many points, so we have to count them. Okay, so here we go. The first step, of course, is to figure out the equation of that line. I'll call it L1. And let's just do the standard procedure, the rise over run type of situation. So 202 minus 24, 4 minus 20. And that is 178 over minus 16. And I'll just convert it to a decimal because I don't want to write out that fraction all the time. So then we have, that's the slope. And therefore we have minus 11.125x plus b. And I'll just sub in either one of those points to get b. So minus 11.125 times 20 plus b. And then when you solve for b, you get 246.5. Okay, so that means the equation of that line L1 is y is equal to minus 11.125x plus 246.5. Okay, not the prettiest equation, but that's okay. So now we have to set this equal to this, because those two lines have to intersect. This line is y equals mx, and this line is L1, and this is the equation for L1. So mx would be equal to minus 11.125x plus 246.5. Okay, so far so good. And then now let me think about this. Should I solve for x or should I solve for m? I think you can, either way is fine. It doesn't really matter, I think. I don't know, maybe I'll just solve for x. So, and then in the end I'll just try to figure out what is m. So if I bring everything over, it's like this, factor out the x, and I get m plus 11.125, 246.5, and then just isolate for x. And when you do, you get this m plus 11.125. Okay, so now from the question, you can see that x, they're giving us endpoints. They actually even call it endpoints. And one endpoint for x is 20, and the other one is 4. So that means that x is between 4 and 20 inclusive. So that's very important. So since x is this, that means that is between 4 and 20 inclusive. So x is between 4 and 20, but x is equal to 246.5 all over m plus 11.125, correct? All right, so then now we can proceed with this. Multiply through by the denominator, and we'll get 4m plus 11.125, 246.5, and then 20 times m plus 11.125, like that. And then let's just multiply out 4m plus 44.5, I believe, and then 246.5, 20m plus 222.5, and then I'm going to do this separately. I'm going to do that, and then I'm going to do that, so because there's two different conditions, so let me just do it separately. For the first one, this one, it'll be 4m is less than or equal to 202 when I bring the 44.5 on the other side. That means m is less than 50.5. Okay, so that's my first condition. For this guy, it'll be 20m is greater than 24, and therefore m is greater than 1.2. Okay, so now I'll combine them. It's getting a little confusing up there. So now if I combine them, it's going to be between 50.5 and 1.2. And now m has to be an integer, so m is going to be 2, 3, 4, all the way up to 50. And that looks to me like 49 values. So 49 is the answer to this question. 4 semicircles are arranged so that their diameters form a 6 by 8 rectangle. A circle is drawn through the 4 vertices of the rectangle. In the diagram, the region inside the 4 semicircles, but outside the circle, is shaded. The total area of the shaded region is A. What integer is closest to A? Okay, so a few things I think I need to label. The first thing I will do is draw a line from one end of that rectangle to another. And then this is a rectangle, so that's obviously a right angle. Now, if that triangle, that line that I drew, that blue line, when it makes a triangle with that right angle, that proves that that blue line is the diameter. That's a property. That if you have a triangle that's a right angle inside a circle, then that line, that hypotenuse, is the diameter. Okay, so that's pretty good. And then I need to label a whole bunch of stuff here. So this I will call X. This is the same, so that's X. This I will call Y. That is the same. That shaded region is Y. And then I've still got to label some stuff. That little region I'll call A. That little region I'll call A. That region B. That B. And I think that should be it. And then, of course, the 6 by 8 rectangle, we know that, so I don't want to write. Well, I could write it in if I wanted to, but you guys understand it's a 6 by 8. So the first step is let's try to figure out what is D. So D squared using Pythagoras would be 8 squared plus 6 squared, right? Because it's a 6 by 8 rectangle. Those are the dimensions of the rectangle. Solving for D, you will get 10. And therefore, the radius of that circle would be 5. Okay? Now, before I continue, the A that, oh boy, oh geez, I labeled A and they have A. Let's just call it shaded region. I've already labeled it, so. The shaded region that they are referring to, what is that in my question? It's 2x plus 2y, right? So this is basically what I'm trying to figure out. That I just want to have a goal there. Okay, so now let's talk about this. The entire circle that's not shaded, the white circle, is 2a plus 2b plus the rectangle, correct? And that would be equal to pi r squared. Yes. So pi, r we got 5, so that's 25 pi. 2a and 2b, that I don't know yet, so I'll just leave it like that. But the rectangle, that's easy. That's 6 times 8. 6 times 8. So 2a plus 2b is 25 pi minus 6 times 8, which I believe is 48. So that is a very, very good finding. Okay, so now we need to, now what do we need to do? We need to figure out that we need to incorporate the x's and y's, these guys. Okay, so if you look at this one, this semicircle, right, and this semicircle, in terms of our lettering, it's x plus a, but there's 2 of them, so times 2. And very similarly, if you look at that semicircle and that semicircle, that, in terms of our lettering, is y plus b, but there's 2 of them, so times 2. But what are they? If you take those 2 smaller semicircles and combine them, it would be one circle. And that would be pi r squared. I'll just call it r1 for now, where r1 is the radius of that smaller semicircle, or if you combine them, a circle. And then the bigger one, same thing, it'll be pi r2 squared, where r2 is the radius of that semicircle, and of course if you combine 2 semicircles you get 1 circle. So this is the way of combining all those letters. Now r1, since that side was 6, r1 would be 3, so that's going to be 9 pi. And then r2, since that side was 8, r2 would be 4, so if you square it would be 16. So that's pretty good. We got 9 pi plus 16 pi. And then this one, I'm going to have to expand it, 2x, 2a, 2y, 2b. And then I'm going to combine the a's and the b's. The 2a and the 2b I'll combine. And the 2x and 2y I'll combine, because this is what I'm trying to get, and that's 25 pi. Okay, we're almost done. We're almost there. This 2x plus 2y is what I'm trying to figure out. This I know is this guy, so put that in there, 25 pi minus 48. And then we are almost done. There's 25 pi's on both sides cancel. 2x plus 2y, therefore, is 48. And 48 is the answer to the question. A park has 4 paths, as shown in the map below. It takes 2 minutes to walk along the path from A to B, 3 minutes to walk along the path from B to A, 3 minutes to walk along the path from B to C, and 3 minutes to walk around the path that begins and ends at B. Rashika goes for a walk starting at A, walking only in the directions indicated along the paths, never stopping to rest and finishing at C. If the walk takes a total of t minutes, how many possible values of t are there with t less than or equal to 100? So the first thing I want to do is get a lower boundary, because that is very important. Now obviously t, since it's a number of minutes, it has to be positive, right? And everything is in integers here. This is 2 minutes, this is 3 minutes, this is 3 minutes, and this is 3 minutes. So since everything is an integer, the total time will also be an integer. So what's the shortest? The shortest path is direct from A to C. You don't come back, you don't swivel or circle around. So let's label them. A to B was 2 minutes. So that's 2 minutes. 3 minutes to walk from B to A, so that's 3 up there. 3 minutes to walk from B to C. And 3 minutes to walk around the path that begins and ends in B, so that's 3. So the shortest is directly going from A to C, starting at A and finishing at C. So the shortest would be 5 minutes. So 5 is the lower end of the boundary, and that's very important. I'm a little surprised they didn't mention that 5, and maybe because they wanted you to figure it out, but that's crucial. So the maximum values, the maximum number of values, number of integers between 5 and 100 inclusive will be 100 minus 4, which is 96. Now, I am confident that the answer is not 96, because that would be way too easy. But that's sort of our starting point. And then what we have to do is figure out what values we cannot get, what integer values we cannot get. Okay, so let's analyze this. Okay, so I am going to actually label these some letters. I'm going to, whatever. I mean, I don't want to use A, B, C, D, because they've already used those letters. So let me just use W, X, Y, and Z. It doesn't really matter. Okay, so some path would, in terms of its number of minutes, would be the number of times you went on W times 2. So if you went on W, say, twice, each time with 2 minutes, so it would be 4 minutes, right? That's the calculation. And then 3 times X plus 3 times Y plus 3 times Z. Now, I'm not saying that you're going to go on every single one of these paths, but that would be the total number of minutes. So that's basically T. Now, a few things that I noticed here. When you go from A to B, if you come back, right, then you end up at A again. So that means then you have to go again from A to B. So that means W has to be greater than X. Yeah, there's no way that you can come back. See, if you go from A to B and then you come back to A, then it's equal. But then you still have to go forward to B again. So you can't get stuck at A. So W has to be greater than X. And then also W has to be at least 1. See, X doesn't necessarily have to be 1. It could be 0. You don't need to take that path. But you have to take the path from A to B in order to eventually get to C. So W has to be at least 1. And then I also conclude that W is x plus 1. No matter what x is and W is, that relationship guaranteed. And you can try it many times. And it doesn't take that much difficulty to figure out that W is equal to x plus 1. Now Z is all alone, so I can't correlate it with anything. And Y has to be 1. It can't be anything else, because once you are here, if you want to complete the path to C, you go to C, and therefore Y is going to be 1. Y can never be anything other than 1, because you can't come back from C. Once you're at C, that's it. It's game over. So this is very important analysis of that path, and I'm going to plug those numbers into here and see if it helps me. So W, that one, x plus 1. Okay, I got my 3x. Y, I have concluded is 1. And the Z is by itself. There really isn't much I can do with Z. So if I expand this, this is 2x plus 2 plus 3x plus 3 plus 3z. And this is 5x plus 5 plus 3z is equal to t. And then I'll factor out of 5. I get x plus 1 plus 3z is equal to t. And then just for the sake of, not that you really need to, since that x plus 1 is w, I'll just put that w in there. Okay, so I've got actually a pretty decent equation. Not bad, right? I mean, I still haven't answered the question, but this will allow us to answer that question. Okay, so now we can go back and discuss this. Basically, we are going to be able to get a lot of integer values. Of these 96, I'm confident I could probably get most of them. Because look, this equation, this all-important equation, tells me that if I can plug in some values of w, and w, remember, is going to be at least 1. Now z can be 0, so z doesn't necessarily have to be anything. Z is greater than or equal to 0. But w and z are integers, so if I plug them into this equation, you're going to get a lot of integer values. So my question is not so much what integers can I get, my question is what integers can I not get with this equation. And there's different ways of figuring it out. My way is that, look at this equation here. Multiples of 5 are guaranteed, right? If no matter what w is, you're going to get multiple. If z is 0, and you put in 1 for w, 2 for w, you're always going to get multiples of 5. But you're also going to get everything that is 3 more than a multiple of 5. And that's very clear in that equation. So pretty much every number that you can get with 5 plus a multiple of 3, 10 plus a multiple of 3, 15 plus a multiple of 3, and so on. You guys get the point. You'll be able to get every single number probably in that range up here. But there's a few numbers you will not get. And that is the key to the question. So which numbers can you not get? Those numbers are not get. You can't get a 6. Try it. You won't be able to. You won't be able to get a 7, a 9, and a 12. Those are the integers that you cannot get. So from this full list of 96, these 4 are not able to be calculated with this formula. So the final answer would be that full 96 minus these 4, and that gives you 92. And 92 is the answer to this question. Aaron has a 1x7 grid consisting of 1x1 squares and follows the process below to construct a pattern. Place an X in any empty square. If 3 or more consecutive squares each contain an X, stop and do not add any more X's. Otherwise, go to step 1 and continue the process. For example, in a smaller 1x4 grid, there are 3 different patterns that can be constructed. The last pattern may be obtained by placing X's in order in squares 1, 2, 4, and then 3. By applying this process starting with the empty 1x7 grid, how many different possible patterns can Aaron construct? All right, so assuming you understand the question, here we go with the solution. So we've got 7 of these guys, right? So 1, 2, 3, 7. Okay. Now, we want to obtain a situation where the maximum number is 3x, and then you stop. Let me just, if 3 or more consecutive x's each contain x, stop and do not. So that's when the game stops, I guess. When you have a 3 or more consecutive squares each contain x. Okay. So it's sort of a game. You're trying to fill it in without getting, I guess, until you get to 3 or more. Yeah. So for example, let's experiment here. It looks like if you have 7 different, you can obviously just put 3 like this, 1, 2, 3, and then you're done, because that would satisfy. If 3 or more consecutive squares each contain x, stop. Okay, so there I've stopped there. So it's obvious that I could get 3. I'm just experimenting. Can I get 4? And let's see here. X. I'm not going to put another x immediately after, because then I'd have to stop. But I can put an x here, and then I put an x there, and then I'd have to end the game. So 4 x's is possible. And I'm pretty sure that 5 x's is also possible. Let me just quickly do it. So x. Okay, can't put an x there. I can't put an x right beside it, but I put an x there. Put an x there. I still haven't gotten 3 in a row, but then there I got 3 in a row. So 5 is possible. And let's see what happens with 6. X. That's 1, 2, 3, 4, 5, and then 6. Okay, so I had to kind of, that's interesting. I had to keep one sort of in the middle somewhere. Not exactly in the middle, but you guys understand, in between. Now let's see if 7x is possible. If 7x is possible, because each of these will have multiple. Like this is just one example. I'm sure there's more than one for 3x, more than one for 4x, more than one, and so on. Let's see if 7x is possible. There, and then there. No, 7x is not possible. Not possible. Yeah, try it and you'll see. You won't be able to put 7x's in the boxes and follow the rules of the question. So I'm really just concentrating on these guys, and that's all this question is. Now, it's not so much that it's difficult, it's just really time consuming. And I always say on math contests, you don't have any time. You know, you have probably 3 minutes a question. So I think that's the challenging part about this, is how time consuming it is. But let's just see. So we've got 3x, and the 3x, I'll just write them all out, and I'll denote the empty boxes with a 0. So these are the patterns that you can get by following the instructions of the question, and that result in 3 x's in a row. And that would be 5 of them. So there we go. Now 4x, there's quite a few. There's the ones that you sort of have 4 in a row, and you just keep moving them to the sides there, like that. X, 0, and then the x is at the end. So that's 4. But then there's several more, and I'll paste those in. So these ones are 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of those guys. So we got 12 of those. Okay, now we're up to 5x. 5x, we've got these ones, the ones that are right in a row. They're going to have, I believe, 3 of those. And then, so there's 3 of those guys. And then you have a whole bunch of other ones that are done a little bit differently. And these groups are the ones where you can see that they have put some of the empty ones in between. And there's a whole bunch of those. There's 15 of those. And then finally, the 6x. Fortunately, there isn't that many of those guys. There's only 4 of them. and they're of this nature. X0, X, 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 and then X, X, 0, X, 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 X. So there's 4 of those guys. So 5 plus 4 is 9, 9 plus 12 is 21, 21 plus 3 is 24, 24 plus 15 is 39, and 39 plus 4 is 43. Therefore, 43 is the answer to this question.